Now let's talk about receptors and neurotransmitters. Receptors and neurotransmitters. As we said, we have sympathetic nervous system and parasympathetic nervous system. We have different types of receptors for them. Let's say in parasympathetic nervous system we have cholinergic receptors, and in sympathetic nervous system we have adrenergic receptors. What kind of cholinergic receptors we know? We know two types of cholinergic receptors. The first one is a nicotinic receptors, and second one muscarinic receptors. Why they nicotinic and why they muscarinic, and how do they work? They nicotinic receptors because they sensitive to nicotine, yeah, and muscarinic because they sensitive to muscarine, the mushroom alkaloid. But both these receptors are sensitive to acetylcholine, and acetylcholine is a endogenous ligand for them. Nicotinic receptors are subdivided, let's say, into two types or two subtypes that we really need to know. In real situations, much more subtypes, but I would like to put two types only here, two subtypes, an N subtype and an M subtype. What does it mean, N? N means nerve, yeah, and they present between neurons, between neuronal cells, and M related to muscle. So it is a skeletal, they present on skeletal muscles, and it is a nerve-muscle junctions. Both these types of nicotinic receptors are ion channels, and if we would like to be more precise, they are ligand-gated ion channels. Let's illustrate that. So we have acetylcholine molecule attached to this ion channel, and ion channel opens and sodium ions are going inside the cell, and as a result we have depolarization, yeah, and maybe action potential generation. What is interesting? Interesting that ion channels can be present in three different states. What kind of states? The first state is a closed but ready to open. We have two gates in every channel, M gate and H gate. So we have opened H gate and M gate is closed. This state, like initial one, as a ligand attaches to this ion channel opens. So we have opening in H gate and we have opening in M gate, and this second state called open. In this situation, in this condition, sodium ions are going inside and depolarize the cell. And third state called inactive. It is a situation when M gate is open and H gate is closed. What is important? Important that transition occurs only from inactive to ready to open state, and never to open state. So inactive channels are unable to become opened. Yeah, they should go to closed but ready to open state, and after that they can be opened.